Okay, hi everyone. Today we'll start with a new chapter, inshallah, alcohol and ethers. Then I explain slide by slide also. If you have any question, you can ask me or any misunderstanding. Okay, now alcohols and ethers. Look here, he said alcohols contain a hydroxyl group bonded to an sp3 hybridized carbon atom. That meaning the condition here, shart, that meaning the OH bonded to the carbon. This carbon must be sp3. Look, all this OH bonded to the carbon, this carbon sp3, this carbon sp3, this carbon sp3. Okay, and we have three types of the alcohol. We have a primary alcohol when the hydroxyl group bonded to the primary carbon. Okay, we have secondary alcohol when the hydroxyl bonded to the secondary carbon. This carbon is secondary carbon. And we have tertiary alcohol when the hydroxyl group bonded to the carbon, to the tertiary carbon atom. Okay, like this. This carbon here is tertiary carbon atom because this carbon bonded to the another three carbon atoms. Now the ether, okay, the ether have two alkyl group bonded to an oxygen atom. Okay, alcohol no, one alkyl group bonded to the one oxygen atom and the other is hydrogen. But ether no, we have alkyl groups bonded to the oxygen atom. That means this R group and this R group bonded to the oxygen. R bonded to the oxygen. This the ethers, and we have two types of ethers. We have symmetrical ether and unsymmetrical ether. When I say symmetrical ether, that meaning this R group identical to this I group. That meaning both the R groups are same. Okay, both of them are same. But here unsymmetrical ether, no. This ethyl and this methyl. That meaning not identical groups. Okay, here the meaning for unsymmetrical and symmetrical. He said both alcohol and ether are organic derivative of H2O. Okay, he said they are derivative for the H2O. Okay, why? Because the same thinking, we think just replace the hydrogen with the alkyl group. Okay, for this reason is derivative for the H2O. From by replacing one or both the hydrogens on the oxygen atom by R group. Okay, by R group. That means if you take the H2O, replace one hydrogen by R group, it will give you alcohol. Replace both of them by R groups, alkyl groups, give you ether. He said here, draw all constitutional isomers having molecular formula, this molecular formula C4H10O. Classify each compound as a primary, secondary alcohol, okay, or symmetrical and unsymmetrical ether. Yani from this molecular formula, I want to draw all possible alcohol and ether and classify all the alcohol primary, secondary, tertiary, or the ether, it will be symmetrical or unsymmetrical. Okay, this nice homework. Now, as we know, for the first, we take how to give the name for the organic compound. Here we talk about alcohol and ether. Okay, the first thing we'll take with alcohol, how to give a name for alcohol compounds by using IUPAC system. Okay, the IUPAC system. Then number one, like this example, give IUPAC name for the following alcohol like this. Okay. Okay. Number one, find the longest carbon chain containing the carbon bonded to the OH group. Okay, that meaning we'll find the longest chain. This is the longest one, or this, no problem. Okay, with bent, without bent, no problem. But we want with further carbon atoms. Okay, the longest chain of the carbon atoms. That meaning 1, 2, 3, 4, 5, 6, or 5, 6, the same thing, no problem. Okay, on the carbon number 3, 1, 2, 3, we have hydroxyl. That meaning the hydroxyl must be bonded to this long chain. Okay, now Find the longest chain, carbon chain containing the carbon bonded to the OH group. Okay, this the longest chain, carbon chains. Okay, now the second, number the carbon chain to give OH group lower number. Okay, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. No, it will be 1, 2, 3, 4, 5, 6. Okay, because don't say 1, 2 because the methyl it will be take lower number. No, methyl not important. The hydroxyl group is the active group here. Is the functional group for this compound. Okay, it will be 1, 2, 3, 4, 5, 6. Okay, now on the carbon number 3, what we have? We have hydroxyl. On the carbon number 5, we have methyl. Okay, now he said here, look here, where is? Okay, change the E ending, for example, hexane, the E here, the E, by all. Okay, hexane, it will be hexol. Okay, hexanol, sorry, hexanol. Hexane will be hexanol. Methane, it will be methanol. Ethane, it will be ethanol. Propan, it will be propanol, like that. Now, look, 5-methyl, we have here on the carbon number 5, we have methyl. 3-hexanol. What this 3 number? 3 number, okay, refer to the position of all. Where is the all? At any carbon, at carbon number 3. That meaning 3-hexanol. We know that meaning the OH group on the carbon number 3. Okay, 3-hexanol. Okay, I hope it is clear. If you have a question, you can ask me. When an hydroxyl group is bonded, okay, when an hydroxyl group is bonded to a ring, okay, now we have cyclic compound. Okay, we have cyclic compound. Okay, the ring is numbered beginning with the OH group. That meaning always the hydroxyl group, it will be at carbon number 1. Okay, all the times the hydroxyl group, it will be at carbon number 1. That meaning this, it will be 1 all the times. Okay, and anyone is best 1, 2, 3, 4, 5, or 1, 2, 3. No, it will be 1, 2, 3, like that. Okay, now because the functional group is always ticket position number 1, and the 1 is usually omit from the name. That meaning we don't write the number 1 for the cyclic compound, because we know all the times the hydroxyl group, it will be tick number 1. Okay, for example, like this. Look, 3-methyl cyclohexanol. Don't say 3-methyl. Okay, cyclo 1-hexanol. Okay, here 1. Okay, or here 1 cyclohexanol. Okay, we don't need to draw to write number 1 here. Okay, because we know all the times for the cyclo, this is the cyclo compound. The cyclo compound, the hydroxyl all, it will be take number 1 all the times. Okay, it will be 3-methyl cyclohexanol. Okay, now take this. This, it will be number 1, this carbon all the times 1. Okay, anyone is best 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. No, it will be 1, 2, 3, 4, 5. Okay, then 2 we have on the carbon number 2, and 5, 5, because we have 2 alkyl group on the carbon number 5. Trimethyl, look, this methyl, 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 identical groups, to be trimethyl cyclohexanol. Okay, don't write one cyclohexanol, sorry. Okay, that meaning we don't need to write number 1 here. Okay, because the hydroxyl all the times will be take number 1. Look, the OH group is at carbon number 1 always, all the time. Okay, now here common names are often used for the simple alcohol. Look, we use common name الاسم الشائع أو التجاري for the just simple alcohols, for the alcohol with small structure, not with big structure. Okay, how it will be the common name? We have the rule for the common name. To assign the common name, name all the carbon atoms of the molecule as single alkyl group. Okay, that meaning this it will be just one alkyl group. Okay, and add the word of alcohol. For this, any group, this 1, 2, 3, propan. Okay, 1, 2, from the middle, it will be isopropan. Because it is alkyl, it will be isopropyl. Okay, propyl, because it is now alkyl group. It will be propyl, isopropyl alcohol, isopropyl alcohol. This is the common name. Okay, but we don't use this common names for big structure, just for the small structures. Okay, because the big structure is so complex to give by common name. Now, compounds with 2 hydroxyl group. Look, if you have compound like this, OH here, OH here, OH here, OH, OH, okay? Compound with 2 hydroxyl group is called diol, diols, okay? This by using IUPAC system, diols. Or glycol. Glycol, it is not IUPAC system. It is also another system like common names. Okay, for it will be glycol. Now take this methane, ethane. Okay, methane, ethane. This ethane now. Okay, we have on the carbon number 1, on the carbon number 2. What we have? We have cohol. That meaning 1, 2, ethane diol, diol, ethane diol. If you say ethanol, put di here. It will be ethane diol because we have dihydroxyl group. Okay, diol. Take this. How many carbon we have here? 1, 2, 3. 3 carbons. Okay, that meaning it is a propan. Now, propan with 3 hydroxyl group on the carbon number 2, 1, 2, 3. That meaning 1, 2, 3. Propanol, but we have 3. It will be propan triol. 1, 2, 3. Propan triol. This is the IUPAC system. Okay, this is the IUPAC system. Look to here, ethylene glycol. This is the common name. أو اسم تجاري. This is the common name, ethylene glycol. Ethylene, this ethylene. Okay, not ethane glycol, ethylene, because -2 hydrogen. We remove 1 hydrogen from the ethane, put OH here, and also remove 1 hydrogen, put OH here. It will be like ethylene. Okay, ethylene glycol. This glycerol, glycerol. Okay, this is the common name. But the IUPAC name for you, it is the best one, and it is easy for memorizing. Now, take this. Okay, don't look to the trans. Okay, don't look to the trans. You can remove this trans. Okay, because we don't take it as stereochemistry now. Just it is like cohol. We have here pentyl, cyclopentane. Okay, we have cyclopentane here, and we have OH. OH on the carbon number 1 or 2, or you can say 1, 2, or 1, 2, no problem. Okay, that meaning 1, 2, cyclopentanol, but dihydroxyl. It will be cyclopentane diol. Diol. 1, 2, cyclopentane diol. Okay, 1, 2, cyclopentane diol. This trans, you can remove it. Okay, this is not for you. Now, take this. This is just homework. Give the IUPAC name for each compound. This compound, cyclo, also this compound. Okay. Give the structure corresponding to each name. Okay. This it will be easy from this because just if you have the name and to convert the name for the structure, it will be easy than if you have structure and give the name for the structure. Okay, I know this. Now give the structure corresponding to each name. You have this, and also this, and also this. Look, be careful here. We have diol. This diol. That meaning we have 2 hydroxyl group bonded to the cyclic compound. Any cycle, hexane cycle. Okay, yeah, exactly like this. Exactly like this, but here hexane, not pentane. this alcohol. Now, naming for ethers. Okay, naming for ethers. Just give me 1 minute. Now, naming ethers. Take here the ethers. Simple ethers are usually assigned common name. Okay, it will be the commercial name. The common name is the preferred from the IUPAC name. Okay. Now, to do so, name both alkyl group. Okay, easy. Name both alkyl group like this: ether, ethyl, ethyl. This alkyl is ethyl, and this alkyl is ethyl. Okay. Name both alkyl group bonded to the oxygen atom. Arrange this name alphabetically. Okay, if you have asymmetrical like this, okay, you have to put it when you write the name alphabetically. Okay, for this methyl and secondary butyl. Okay, secondary butyl, that meaning B, and M, that meaning B, it will become first. Secondary butyl, this is the butyl. Methyl, this is the methyl ether. Okay, now bonded to an oxygen atom. Okay, bonded to the oxygen atom. Arrange this name alphabetically and added the word ether. Okay, just name the alkyl group and put the ether. Okay, for like this, look, we have this methyl and we have this secondary butyl. Secondary butyl, methyl ether. Secondary butyl, methyl ether. This ethyl, ethyl. We cannot say ethyl, ethyl, ether. Okay. Okay. We use di, try, di. We use di. Okay. There is no try here. We have diethyl ether. For symmetrical, look, for symmetrical, if you have symmetrical like this symmetrical ether, we always use the di-alkyl ether. Di-alkyl ether. If you're alkyl ether, it will be diethyl ether. Methyl dimethyl ether. Dipropyl ether. Dipentyl ether. Okay, like this. And this, it is clear, I think. More complex ether, yani ether with big structure, slightly complex, are naming using IUPAC system. Here we have IUPAC system, okay? One alkyl group is named as hydrocarbon chain. Okay, that meaning one of the alkyl group, it will be the main, it will be the parent chain. Okay, the big one, it will be the parent one. It will be the parent chain. Okay, I will give you example. Don't worry. One alkyl group is named as hydrocarbon chain, and the other is named as a part of substituent bonded to that chain. Okay, like take this. Okay, now this compound. Okay, now this compound, this part alkyl, and also we have alkyl here, but this is the big one. This it will be hydrocarbon, and this it will be substituent on this hydrocarbon. Yeah, and this the small part, it will be just substituent. Look, okay, substituent on the carbon on the big chain. Now, name it part of substituent bonded to that chain. Name, look here, number one, name the simpler alkyl group زائد an oxygen atom as alloxy. Okay, now we know if you have alkyl group, it will be alkyl group, but alkyl with oxygen, it will be alloxy. This a new part, alloxy. Okay, alloxy, this general name. Alloxy, maybe it will be methoxy, maybe ethoxy, maybe butoxy, like that. Okay, name the simple alkyl groups زائد an oxygen atom as alloxy group. Alloxy, I said this alkyl meaning different carbon, maybe methoxy, maybe ethoxy, maybe butoxy, like that. Alloxy substituent, by changing the YL, we have alkyl, change the YL ending of the alkyl group to the oxy. Okay, that meaning like this, butyl, okay, it will be butoxy. Ethyl, it will be ethoxy. Methyl, it will be methoxy. Okay, now Name the remaining alkyl groups as alkan, and the big part, it will be just alkan, with alloxy group as substituent bonded to the chain. Okay, we take example like this. Give the IUPAC name for the following ether. Now, take this. Okay, now, this is complex structure. Okay, if you want to use the common name for the ether, this is ethyl. Yes, this ethyl, but this, it is complex to give the name by this. What he said, it is difficult to give the name for this alkyl group. Okay, now we have the IUPAC system. Okay, دائما, always the IUPAC system, it is the best choice to give the name for the complex structure. Okay, now number 1, name the longer chain as alkyne and the shorter chain as alloxy group. Now take this 1, 2, 3, 4, 5, 6, 7, 8. 8 octane. Okay, octane. Okay, no problem. We have octane here. And this, any group, this ethane. Ethane with oxygen, it will be ethoxy. Okay, now put number, it will be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. No, it will be 1, 2, 3, 4. Okay, it is the best, because the substituent, it will be take the lower number. We know that. Now, 1, 2, 3, 4. The substituent on the 4, on the carbon number 4. That means 4 ethoxy octane. Okay, 4 ethoxy octane. خلاص. Look, it is easy and short name. 4 ethoxy octane. This ether. Why ether? Because we have ethoxy group bonded to the alkane. This, it will be ether. Alkyl, oxygen alkyl. This is ether compound. Okay, this is ether compound. Name each, give the name for the following ethers. Here, this homework for you. Look, this unsymmetrical, this also unsymmetrical with cyclic, this is symmetrical. Okay, this for you. Try to resolve this and easy examples. Now the physical properties for alcohol and ether. Now alcohol and ethers and epoxide. طبعا epoxide طلبة is cyclic ether compound. Okay, but we don't take it here. Just we take the alcohol and ether except dipole interaction. He said here dipole interaction. Why dipole interaction? Because we have oxygen atom, high electronegativity. If you compare the oxygen, this oxygen with the carbon, that meaning this, it will be partially negative, and this, it will be partially positive. Okay, partially positive, partially negative, dipole. Okay, دو قطب يعني. Dipole. That meaning if you have dipole group, that meaning we have dipole interaction. Yes, exactly. Okay, alcohol. Also capable for the intermolecular hydrogen bond. Okay, that meaning alcohol also can make hydrogen bond. Why? Because alcohol has here hydrogen atom bonded to the oxygen. This hydrogen atom is partially what? Partially positive. Okay, this hydrogen is partially positive, can make hydrogen bond with another shape of electron, oxygen for the oxygen atom for the another compound. Okay, like this. This alcohol and this alcohol, 2 molecules of alcohol. Okay, that means look to the hydrogen bonding between the hydrogen, this hydrogen partially positive, and the shape of electron for the oxygen. Okay, this is the hydrogen bond. Okay, this is the hydrogen bond. That meaning for the ether, we have dipole interaction. But alcohol, we have dipole, and we have hydrogen bond. Okay, and because they possess a hydrogen atom on the oxygen, making alcohol much more polar than ether and epoxide. Okay, don't look to the epoxide. You can remove the epoxide. That meaning making alcohol much more polar than ether. Okay, than ether. Now, and he said here, A steric factor effect to the extent of the hydrogen bonding. Although all alcohol can make the hydrogen bond, increasing the number of R groups around the carbon atom bearing the OH group, decrease the extent of the hydrogen bonding. Yes, if you have big alkyl group here, that meaning the hydrogen atom, it will be weak here. Okay, because the steric effect. Okay, no problem. Thus, tertiary alcohol are, look, this is the tertiary alcohol. This increase ability to hydrogen bond. Okay, this increase ability to hydrogen bond. That means this increase the steric effect. Okay, now if you take this and this and this is a primary alcohol, this secondary alcohol, this tertiary alcohol. Anyone can make best hydro or strong hydrogen bond. Okay, the primary alcohol. Why? Because the less steric effect here. إعاقة فراغية قليلة. Less steric effect here. Okay, this group is small, but here look, we have here carbon with a 3 alkyl group. This 3 alkyl group can make some steric affecting to the hydrogen bond. Okay, now the tertiary alcohol are less able to hydrogen bond, whereas the primary alcohol, it is the best one to make the hydrogen bond. Look here, increase ability hydrogen bond, but here increase the steric effect, hand runs. Okay, increase the steric effect. Now this is just physical properties. How this factor affect to the physical properties of alcohol and ether. Okay, any factor, dipole-dipole interaction, hydrogen bond, like this. Okay, and van der Waals forces. We know van der Waals forces can be happen just between the alkyl groups. Okay, between the saturation part, we say that between the hydrocarbon part. Okay, now how this factor affect to the physical properties of alcohol and ether. Look to the here, the properties, we take just boiling point, melting point. Okay, now for compounds of comparable molecular weight, that meaning it is if you look to the molecular weight, it will be the same molecular weight between each other, or maybe near between each other. The stronger, and look here, the stronger the intermolecular forces, the higher boiling point and melting point. Okay, now if you take this just alkane, this ether, and this alcohol. Now alkane, any type of bonding have it alkane. We have dipole-dipole? No. We have hydrogen bond? No. That meaning for the hydrocarbon, like this, just the hydrocarbon, just we have van der Waals forces. This is VDW, van der Waals forces, okay? But if you take ether, we have van der Waals forces, and also we have dipole-dipole interaction. Dipole-dipole for the oxygen carbon, okay? Because oxygen carbon is partially negative, partially positive. And the van der Waals forces, it will be for the alkyl group, okay? Look to the boiling point here, zero boiling point. But look to the boiling point here, it will be 11, okay? That meaning increase the boiling point. Increase the boiling point. Why? Because the increase the ability to bond between the molecular, because the van der Waals forces and the dipole-dipole interaction. That meaning we here need more energy to separate the molecular from each other, okay? Need more energy. Energy, that meaning more heating. It will be like that, okay? More heating. Okay, if we talk about boiling point, melting point, that means the energy, it will be heating, okay? Now, take this alcohol, look, just this alkyl group, van der Waals forces, okay? Oxygen, carbon, dipole-dipole interaction, and also we have hydrogen bond, that meaning we have three different type of bonding. We have van der Waals, dipole-dipole, and hydrogen bond. That meaning we know this, it will be higher boiling point and melting point from the other. Look to the boiling point here, okay? 97, oh, so high, okay? If you compare the 97 with the 11 or the 0, it will be this big difference between them, okay? Why? Because the hydrogen bond. Okay, the hydrogen bond. And here, boiling points increase as the extent of the hydrogen bond increase. Now we said the primary alcohol make best hydrogen bond or strong hydrogen bond. The secondary alcohol, the hydrogen bond, it will be weaker, and the tertiary alcohol, it will be the weaker one to make the hydrogen bond. Why? Because the steric effect. We said here because the steric effect. Yani this exactly like this, طلبة. Like this. Okay, exactly the same thing because the steric effect. Okay, steric effect can be make the hydrogen bond stronger or weaker depending on the alkyl group. If you have tertiary alkyl group, that meaning your alcohol tertiary, that meaning it will be weaker to make hydrogen bond. If you have secondary or primary, the hydrogen bond, it will be stronger than tertiary alcohol because the steric effect. Now he said here another alcohol ethers having less than 5 carbons. If you have alcohol and ether with 5 carbon atom or less, less than 5 carbon atoms are H2O soluble, can be soluble in the water. Okay, like ethanol, like propanol. Propanol can be soluble in the water. Okay. Because they each have an oxygen atom capable to make hydrogen bond with the H2O, and if you have hydrogen bond between alcohol and the H2O can be soluble, the molecules can be dissolved with each other to be soluble in the water. Okay. Now, alcohol ether having more than 5 carbon atoms are H2O soluble. Okay, 6 carbon atom and more than 6, it will be insoluble in the water. Why? Because the size of the alkyl group of the hydrophobic group, it will be bigger. Okay, it will be big because look here, because the nonpolar alkyl portion, the part of the alkyl group, is too large to dissolve in the H2O. We know the alkyl is polar or no? Non-polar, and the H2O polar. That meaning non-polar cannot be dissolved on the polar. Okay. For here, because we have alkyl group, the alkyl group is it will be big. That meaning cannot be dissolved easily in the H2O. Okay. Here he said alcohols, ether of any size are soluble in organic solvent. طبعا alcohol والether from carbon number 1 and the big one, it will be soluble in the organic solvent. طبعا, of course, because alcohol and ether is organic compound, can be dissolved in the organic solvent, no problem. Both of them is hydrophobic. And here, rank the following compound in order of increasing boiling point. Look, this. Okay, put it rank, يعني ترتيب the following compound in order increasing the boiling point. يعني anyone has low boiling point, anyone has high boiling point, put it. Okay, think about the structure, about anyone have hydrogen bond, dipole-dipole interaction, like that. Okay, also this and this and this. I think easier. Explain why dimethyl ether and ethanol are both water soluble. Why? طبعا, you know why. But the boiling point of ethanol, look, Harduca water soluble. The boiling point, no. The boiling point of ethanol, 78 degrees, is much higher than the boiling point of the dimethyl ether. Dimethyl ether boiling point minus, okay, minus 24. Minus 24. Okay, the boiling point. But you can look to the difference between of them. It is so high. Why? You know. Why?
Hydrogen.
Yes, because the hydrogen point. Okay. Now we finished from the naming, the properties for the alcohol and ether. Here طبعا of course it is so important to know how we can prepare the alcohol and ether compound. Okay, that meaning we take the preparation of alcohols and ether preparation. Okay, that meaning if you don't have alcohol, don't have ether, and how you can prepare this compound. طبعا we can prepare from the other compound. Now, alcohol and ether are both common products of nucleophilic substitution. That meaning if we make substitution reaction for special compound, nucleophilic substitution reaction can give us the alcohol and ether. Okay, like what? They are synthesized from the alkyl halide. That meaning we have alkyl halide. Look, we have alkyl halide here. Okay, all this is alkyl halide. By what? By SN2 reaction. Okay, what meaning SN2? SN2 meaning nucleophile, it will be attacked from the backside to give you what? To give you the substitution reaction. Okay, if your nucleophile OH, that meaning BR it will be removed, OH it will be replacement with the BR, that meaning your product it will be what? Kuhul. If your nucleophile ethoxy, methoxy, butoxy, that meaning the product it will be an ether. Okay, easy. Look this methoxy, SN2 reaction, Cl it will be removed, that meaning it will be ether, methyl propyl ether, okay, or propyl methyl ether. Look to this ethoxy, okay, ethoxy it will be attacked, Br it will be removed, okay, by SN2 reaction, it will be give you ether. That meaning easy. Just from the alkyl halide, we can prepare the alcohol and ether by using what? By using substitution nucleophilic reactions. This nucleophile, all this طلبة nucleophile. Be careful. All this nucleophile. Nucleophile from what? طلبة يعني قاعدة like NaOH, NaOCO3, KOCO3. Okay, here. NaOH or KOH, like this. The same thing here. NaOCH3, KOCH3, the same thing here. That means this strong base, طلبة, strong basis. Strong basis. The preparation of ether by this method is called the Williamson ether synthesis. Okay? Williamson ether synthesis. That meaning by using strong base, just reaction with alkyl halide, it will be give you alcohol or ether dependent on the base you are using. Okay. Now, طبعا this is the history for this longer on the past. He said, for example, isopropyl methyl ether can be prepared from this base CH3O minus Na طبعا K as you like, and 2 bromopropan, this 1A, or from this CH3 by 2 CHO, this compound, okay, this part, and a bromoethane, because the mechanism is SN2, the preferred path using the less strict handles. Okay, now I explain for you this. Take this. We have this ether. Okay, now I want to prepare this ether from the alkyl halide and the base, the nucleophile. Okay, anyone is best to use this alkyl halide. Yani this part it will be the base, and this part it will be from the alkyl halide, or reverse. This part it will be the base, and this part it will be the base, and this part it will be the alkyl halide. Anyone is best. He said here like this. Okay, that means دو احتمال هيا. Okay, we have 2 choices. Okay, like if we use this base CH3O minus like Na, potassium, okay, this our base, and this it will be attack here on this carbon and remove Br, okay, to give you the product. Or reverse, we use this alkyl halide and this our base, okay, and this it will be attack here SN2 reaction, and this it will be remove to give you the product. Anyone is best.
Yeah, I will look
Yes.
say that.
A, this the يعني the line A or the line B?
A.
A, why?
Nucleophilic.
A and B, why? I want why? I want why?
Cystolytic effect.
Okay, look.
Say the strong base ده.
No, yes. Strong base and the strict effect. Do تأثير هي. We have two factors here, okay? We have the strong base and we have the strict effect factor. Look to this. This strong base or no? Anyone's in strong base, this or this? Anyone is strong base, this or this? Why? Okay. Anyone is more stable, it will be weak base. I will give you this idea. Anyone it will be more stable, it will be weak base. Anyone is more stable, this or this? This or this? Think about this negative charge, طلبة, this negative charge. Anyone is strong negative charge, this or this? يلا. Okay, look, another word. This one alkyl group increase the negative charge. Here, big alkyl group increase the negative charge. Anyone is stronger than other?
B سيدة.
A.
B.
Yes.
Yeah,
B.
B.
Okay, B. Okay, this B, look, this B increase the negative charge. يعني not stable, أنا مستقرة. Okay, if I say not stable, that meaning it will be strong base. Okay, it will be strong base. Now, this it will be weaker base. Now, anyone is more strict effect, this or this? More strict effect, إعاقة فراغية. يعني أي واحد أسهل يصير للهجوم إذا واحد يهجم هنا، إذا واحد يهجم هنا، أي واحد. Anyone is easy to attack.
A.
A is easy to attack.
لا B.
No سيدة B.
B. Bochichenko 3 hydrogen atom, a small hydrogen atom. There is no strict effect here. That meaning the nucleophile, it is easy to attack this carbon, okay? But here the nucleophile is difficult to attack the secondary carbon. Why? Because we have big alkyl group here, okay? Big alkyl group, okay? That meaning this pathway, this line, or this choice is best to synthesis this ether. Okay, this is the best one. Why? Because the base, it will be stronger, and the alkyl, it will be less strict effect. But here, no. The base, it will be weaker, and the alkyl halide, it will be with a strict effect. Okay? And he said here, the preferred by using the less strict, look, the preferred path use the less strictly handled halide. Okay, anyone less strict effect, this or this? This, the less strict effect. That meaning this way is the best. If you compare this with this, it will be the right one. This not wrong, but this is the preferred. This is the easy one. This difficult. Okay. Look to here. You understand this, yes?
سيدات الشيء تباركي.
Okay. Okay. Look, I want to prepare this ether, طلبة. Okay? I want to prepare this ether. Okay. Anyone, that meaning you have to make the ether two part. Okay, like this. I will use the paint program. 1 minute. where is okay. Look, I have here look, I have R, oxygen, R. Okay, طلبة, this ether. I want to prepare this ether. Firstly, you have to think. You have to make this ether two-part. Okay, anyone is best to sorry, I will use this color, another color. Okay, anyone is best to make the ether two-part from here or to make the ether two-part from here? Anyone is best, this or this? Now, to get an idea, anyone is the best from the other, you have to think about the alkyl group. This is the alkyl group. This is the R and the R. Okay, anyone is it will be the best base, and anyone it will be the steric effect alkyl group much than the other. Here's the problem. Okay, now I will go to our example. This is our example. Okay, now look, anyone is best to make the two-part from here or to make the ether two-part from here? Okay, now if you make your ether two-part from here, that meaning this, the CH3 with the oxygen, it will be the base, CH3 oxygen, and like for example Na, put Na here, no problem. Okay, and this it will be alkyl halide part, this alkyl halide part. Look, CH3 carbon, CH3 hydrogen, and Br. Okay, here عكسه بالعكس. This it will be alkyl halide, CH3 alkyl halide, and this it will be the base. This it will be the base. Okay, now anyone is best, this react with this to give the product, or this react with this to give you the product? Anyone is the best. Okay, now for this two example, the good idea you thinking, or you have to think about this two reaction. The good idea, look to the steric effect. Look to the alkyl halide. Where is the alkyl halide? This here, CH3Br. Where is the alkyl halide? This alkyl halide. Okay, now this alkyl halide, primary, secondary, tertiary, طلبة
Primary.
primary. Or this
Primary, yes, I did.
No, ciao primary.
secondary.
Secondary.
Both secondary. Çünkü o carbon halogen bonded to this carbon do jiran carbon here. Secondary. Okay, secondary alkyl halide. This look, secondary alkyl halide. This a primary alkyl halide. Now, for SN2 reaction, if you remember, for SN2 reaction, anyone is faster, primary or secondary?
Primary.
Bucci.
or came beside
Or
the
it will came
R2 كمان less steric effect. معناه less steric effect. خلاص. يعني أو reaction أبا قال أبا باشترى أبا قال أبا. خلاص. This easy and fast reaction. This is slow reaction and difficult. Why? Because this nucleophile easy to attack primary alcohol, less steric effect. This base or this nucleophile difficult to attack secondary alkyl halide. زين secondary alkyl halide طلبة secondary alkyl halide كيش باشترى SN1 or SN2؟
SN1.
خلاص SN1. اوكي وهير ام دفنا هي وهير اني ميكان هير SN1 تشيل بيت انا
رشد بسيدري
تشيل بيت بوتشي شرط SN طلبة SN1 شرط ويتشيا alkyl halide secondary and tertiary معناه؟ وبيس تبي strong or weak؟ weak or neutral متعادل. أما بيس neutral أبا؟
لا strong.
strong يعني أبا خلاص SN1 إلا SN2. Okay? That meaning the preferred one is this. Okay? The good reaction it will be this way, and this way it will be not good reaction. تمام؟ التذكير طلبة واضحة عنا هشتا؟
درسها سيد.
doesn't stand. Okay. Okay, inshallah. Look to here. A hydroxide nucleophile is needed to the synthesis an alcohol. He said what he said? He said hydroxide nucleophile. Okay, that meaning we need the hydroxide. Where's the hydroxide? This is the hydroxide. Okay, now is needed to synthesize an alcohol. Okay, now alcohol, no problem. And salts such as NaOH and KOH are expensive. Okay, this NaOH, the أملاح salts such as NaOH and KOH are inexpensive and commercially available. يعني متوفرة وخلاص. يعني نقرانا. And alkoxide salt is needed to make an ether. Okay, simple. طبعا it is just simple alkoxide such as sodium methoxide. Sodium methoxide, not very complex. Can be useful for the reaction. But other are prepared from the alcohol. That meaning also we can prepare from alcohol our alkoxide salt. Okay. Now, what meaning طلب alkoxide salt? Do you know what meaning alkoxide salt?
Alkyl with O.
Hey, alkyl with O with metal. This. This alkoxide. This. Alkoxide. CH3 oxygen Na. CH3 oxygen potassium. Okay. يعني salt ملحة. يعني nucleophile. يعني he talk here about the nucleophile. Okay. Alkoxide nucleophile. Look. Alkoxide. Hydroxide nucleophile, alkoxide nucleophile. Okay, that meaning if I give you ether, I want to prepare this ether, you have to think about the nucleophile. Where is the nucleophile? Okay, how I can prepare the nucleophile? This is the meaning here. Okay, that meaning if you have ethanol, it is easy to prepare your nucleophile from the methanol. This is the nucleophile, CH3, CH2O. Okay, alcohol is acid or base?
Base.
Base.
Okay, base. If the alcohol react with acid, but it will be acid if the alcohol react with base. Yes. Now you have this alcohol, and we have this strong base. Okay. Now this strong base can be attack the proton here. This is a proton. Okay. This is a proton for alcohol partially positive or no?
Positive.
partially positive يعني acidic معناه؟ خلاص acidic. That meaning if you have base like this, that meaning the base it will be attack the proton. Okay. It will be attack the proton to give you the oxygen negative charged. Oxygen negative charged with Na, it will be salt. It will be ملحة salt. Okay. Sodium ethoxide. Sodium ethoxide salt. ملحة. تمام. Now sodium ethoxide nucleophile or no?
Nucleophile.
خلاص nucleophile. تمام. Okay. Now take this cyclohexane. This cyclohexane alcohol. This. Okay. Cyclohexane alcohol with NaH. طبعا NaH strong base. Okay. That meaning the hydrogen minus strong base attack the proton, give you minus on the oxygen, this minus on the oxygen and Na. Okay, this your nucleophile. Now the nucleophile, look, step number 2, the nucleophile it will be attack the CH3 CH2Br. It will be attack ethyl bromide. Okay, it will be attack the ethyl bromide. It will be give you what? Give you ether. This minus, it will be attack this carbon and Br will be removed to give you this alcohol. Okay, that meaning if I told you prepare for me this alcohol, okay, from this by using any reagent, by using any necessary reagent. Okay, you have to make 2 reactions. Reaction number 1 with the base reaction, this compound with the base, and step number 2. Your nucleophile, okay, your nucleophile it will be react with the alkyl halide by SN2 reaction to give you the ether. Okay, this is the meaning here. Okay, look to this. Draw the organic product of each reaction. That means we have this reaction. What is the product? and classify the product as كحول or ether and symmetrical ether. Okay. Now you have this compound. It will be react with this. That meaning the product it will be كحول or ether.
كحول.
كحول. عافية. Okay. This A. B. You have this. What is the product? كحول or ether?
كحول. راحت له.
نعم عوض.
إيثر.
ether. تمام؟ ether لو كحول.
إيثر.
إيثر.
ether. عافية. ether. Symmetrical or unsymmetrical?
unsymmetrical.
Unsymmetrical. Okay, good. You have this. What is the product? كحول or ether?
إيثر.
Ether. Symmetrical or no?
unsymmetrical.
Unsymmetrical. Okay, good. You have this. What is the product?
إيثر.
Ether. Ether and كحول.
إيثر.
باص سحكن. ها.
إيثر.
H2.
Ether and كحول.
إيثر.
Ether. يلا كيف يجد كحولة ماينس بنش امتحان فصل. اوكي تمام. Okay, now draw the different road. Draw the different road to each ether and state which route is preferred. Okay. Now I want to prepare this ether. I want to prepare this ether by using two-way. Okay. Dureka. Okay. Anyone is best. Anyone is best. Okay. This homework for you. This طلبة exactly like this. Exactly like this. تمام? Exactly like this. Okay? He said, say to me, line number 1 or path A or path B. Anyone is best. This or this, exactly here. The same thing. Okay? I want to prepare this ether by using two-way. And anyone is preferred. Anyone is the best. Okay? The same thing here. The same thing here. I want to prepare this ether by using two-way. Anyone is the best. Okay? Anyone is the best. طبعا طلبة بصلاحية. And you have to break your compound from here, jarake and jarad away from here. Okay? And put it the alkyl halide, necessary alkyl halide and the base. And so anyone is the best. If you make your ether two part from here or from here. The same thing here. Make your ether two part from here and from here. And anyone is to be the best. Okay? The same thing. It is exactly طلبة يعني 100 by 100 like this. Okay? Look. This it make two part ether from here, but this make the ether two part from here. Okay, from here. طبعا طلبة أو مهمة أو بسيارة قلق مهمة يعني محاولتك حلكن. Okay. Okay. Now another homework you have here. Draw the products of each reaction. The products of each reaction. Okay, now, what is the product here, طلبة? كحول ether chia.
كحول أسيدها. بدي NH H ودي H2 البرهن.
دبنا H2 ودبنا O minus Na. معناه؟ زين O minus Na كحول؟
نسيته.
لكن فيها سلطة. Okay, the product it will be salt. Okay, salt. تمام, not alcohol. No. This be
hard salt.
Hard salt. عافية. This سكر. يا عمولي دبنا سلطة ويا دوية دبنا شيا. دبنا ether. Okay. This salt خلاص او صح او امريكا فورما تو ستراكشر بالفيزا. اوكي تو ستراكشر بالفيزا. تمام dehydration of alcohol to alkene. Okay, dehydration meaning remove H2O molecule. Okay, from what? From the starting material. By using what? By using strong acid. Okay, strong acid. Now, the dehydro طبعا
Anyone is base. Dehydrohalogenation. No, dehydration, not dehydrohalogenation. طلبة. Look here. Dehydration. أو طلبة بدل dehydrohalogenation. Okay. أو dehydration. أو dehydration.
هسه
No. Dehydrohalogenation درستها but from the alkyl halide. يعني from the alkyl halide give you alkene. But here from alcohol give you alkene. Okay. أو درستها مشكلة. He said dehydrohalogenation of alkyl halide طبعا chapter 2 is one way to introduce the pi bond. Okay, no problem. Another way is to eliminate water from the alcohol is called hydration. Okay, hydration reaction. Now dehydration meaning like dehydrogenation, dehydrohalogenation. Dehydrohalogenation meaning remove HX. Do you remember that? Dehydrohalogenation meaning remove HCl, remove HBr from the molecule, remove HI like this. But the dehydration, no. Dehydration meaning remove hydration molecule. Hydration يعني OHH يعني H2O molecule يعني water molecule. Okay. Dehydration you can write here dehydration of alcohol بنفيسها minus H2O حتى تظن بنفيسها minus H2O meaning dehydration يعني remove H2O molecule from the starting compound. Okay. Is beta elimination reaction. What meaning beta elimination reaction? We take it before that. Look, this OH group on the carbon alpha. Carbon dewey is beta. That meaning the elimination it will be happened on the between alpha and beta carbon. Okay, remove the hydrogen from here from the beta carbon. That meaning it will be called beta elimination reaction. Okay, in which the eliminating of OH and the hydrogen are removed from the alpha and beta carbon atom. Okay. It will be called beta elimination. Okay. Now beta elimination with strong what? With strong acid give you alkene compound. Okay. Now, what is the mechanism? What happened here? Why, if you have alcohol with strong acid, it will give you alkene? It will be like this. Look here. General features of the dehydration of acid. Alcohol undergo dehydration in the presence of strong acid, okay, to afford the alkene, to produce the alkene. And as illustrated equation number 1, this number 1, if you have alcohol, strong base, okay, that meaning give you alkene compound. And like this also, if you have this alcohol, and طبعا this also strong acid, tosylate acid, it will be also give you the alkene. This TS طلبة this para-toluene sulfonic acid. Para-toluene sulfonic acid. The structure, where is the structure? Toluene sulfonic acid. This is the structure. I will give you the structure here. 1 minute. I will give you the structure. Sharing for you. Where is the chemidro? No, where is the chemidro? Okay. Where is the chemidro now? This. This. We have here CH3, and we have 1, 2. Sorry. 2. This, and we have here CH para-toluene sulfonic acid. This we have caprate, this oxygen, and this OH. But this strong acid. Our proton vary, our proton hydrogen, it is so acidic. Okay, it is so acidic. Our strong acid. Okay, our strong acid. Para-toluene sulfonic acid. Okay. أو مختصرة TSOH. Okay, TSOH. Now, more substituted alcohol dehydrate more rapidly, giving rise to the following order reactivity. Okay, look, more substituted alcohol, okay, increase the rate of dehydration. Okay, increase the rate of dehydration. Why? We give you the reasoning. When an alcohol, طبعا I think in the next slide, here, okay, in the next slide. Okay. طبعا طلبة, you can write here dependent on the stability of carbocation. Right here, dependent on the stability of the carbocation. Okay, because we have carbocation here, and the tertiary alcohol give tertiary carbocation. It will be more faster than primary carbocation. Now, مهم. I will give you the reason and then the mechanism. When an alcohol has 2 or 3 different beta carbon, dehydration is regoselectivity. We have regoselective here, and follow the Zaitsev rule. Okay, now we take it this before that. If you remember the alkene, the more substituted alkene is the major product when a mixture of constitutional isomers are possible. Okay, now look, we have hydroxyl bonded to the carbon. Okay, now this alpha carbon, beta carbon, how many beta carbon we have?
2
2
CH3 وCH2 CH3.
Now, look, I want to focus. If I say how many beta carbon we have, you have to say 3. 1, 2, 3. But if I say to you how many different type of beta carbon, you say to me, do. This is beta carbon 1, and this it is like this. That meaning this beta carbon 2, or this one, or this 2. Okay, but this like this. Okay, this like this. No different. That meaning here we have 2 type different of beta carbon. Okay, now if I remove with strong acid, if I remove this proton, that meaning the double bond it will be here. Yes, the double bond it will be here like this. If I remove the proton from here, the double bond it will be here like this. Okay, the double bond it will be like this. Okay, now anyone is base A or B? A. Why?
or زيادات
زيتف. يعني أو كيش قاعدة؟
Zaitsev rule.
Okay, Zaitsev rule. Okay, Zaitsev rule. This it will be the more substituted alkene, it will be more stable, and it will be the major product. Okay, with a high percentage of yield. Okay, that meaning this it will be high substituent alkene, this it will be low substituent alkene. This 1, 2, 3 alkyl group, this 1, 2 alkyl group. تمام؟ واضح؟ We take that in your first semester. Now, and here, draw the product formed when each alcohol undergo dehydration with طبعا have a strong acid, and label where's the major and minor product. Okay, now take this. How many different carbon we have? How many? Okay, that meaning if you remove this hydrogen and if you remove this hydrogen, no, there is no difference. يعني product كم product احتمالها يا؟ هيك احتمال خلاص هيك احتمال. Okay. This, okay, how many different beta carbon we have?
دو سيدة
دو يعني دو ناتج هي احتمالها هي معنا؟
CH3 CH2.
ايه صح كيف CH3 وبا CH2 CH2. Okay, that meaning دو type احتمالها هي دو product احتمالها هي بنفيسن وكش مستقرة وبوتشي طبعا أوجب صنع هي لا بصح. Okay, now here how many different type of carbon we have?
Do say CH3 or CH2.
عافية. Also do that meaning we have 2 product. Write both of them, and anyone it will be the major one, anyone it will be the minor one. Okay. He said homework, another homework. Wrong the alcohol in each group in order increasing reactivity when dehydration with H2SO4. He said here anyone is faster. Anyone is faster reaction with H2SO4, this or this or this. Okay, this alcohol primary, secondary, tertiary, what?
Tertiary.
Huh?
Secondary.
One? 2 3 أبا tertiary أبا
برايمري سيدة.
وأبا
سكندري.
كيش فاستر
تيرشري. أيوة.
تيرشري سيدة.
كيش slower
primary
primary.
عافية primary. That meaning this it will be faster one and then this and then this. Okay. Why? طبعا dependent on the stability of the carbocation. We take this before that. Also, I will give you the mechanism here. That's the mechanism again. This is the carbocation. If you have tertiary alcohol, that meaning give you tertiary carbocation and it will be more stable. Okay. Now take this. The E1 mechanism for the dehydration of secondary and tertiary alcohol.
سيدة بلا بمينيت.
شو minute? كيف minute?
بس بيت سيدة
هيش
أصدق بار سيدة.
سيدة ما
نعم.
كيف سيدة
أنا سيدة بلا بمينيت. بس سيدة قرت إيوان أني ميكانيزم شرح كي بيزن بما داستي تشي كي بخدي.
سيدة واكيد يامتين أوجهين
لا او يعني هاي كنا اخذناها الميكانيزم طلبها بالكورس الاول.
خدي سيدة مشي نظام.
يعني بلا حسب مش بتشك مش كانينا. هش تجي هش كل دقه معي.
كيمو في سبب ما بيجا سيدة بدي.
شيء؟
ميكانيزم.
ايه؟
الكيمو في سبب ما بيجا.
الكيموفيز ما حاصلها في خطوه.
نا سيدة من نظامي وصاب خدي.
بس تحكي تدزاني بس خبقرة. اوكي بس خبقرة. اوكي كلمة خطوة no problem. اوكي just wait. The E1 mechanism for the dehydration of secondary and tertiary alcohol. Okay, E1 mechanism. Okay, elimination 1 meaning elimination 1. What meaning E1 طلبة? Do you remember the difference between E1 and E2? Why this E1? Why this E2?
أستاذ سترونج واحد ويك واحد يعني
والرايت اوف رياكشن تعتمد على ايش؟
اور سيدة
تعتمد على تركيز ايش؟
كاربوكيشن.
ايه اوكي you only know. Look, the mechanism of dehydration dependent تهميش بالكريا يا كورس او يا سمستر او الهمي. The mechanism of dehydration depended on the structure of alcohol. Secondary, tertiary alcohol react by E1 mechanism, whereas the primary alcohol react by E2 mechanism. Why? Because the carbocation stability. Secondary, tertiary alcohol give you secondary, tertiary carbocation was stable, but the primary alcohol give you primary carbocation not stable. That meaning it will be by E2 mechanism. Okay, now he said regardless of the type of the alcohol, however, strong acid, the strong acid always needed to protonate the oxygen atom to form a good leaving group. Okay, no problem. The E1 dehydration of secondary and tertiary alcohol is illustrated with this compound CH3 by 3SOH طبعا of alcohol viscohol as a starting material. Okay, to form what? To form this is a product. Okay, the mechanism, this is the mechanism. Okay, 3 step. Look, this primary, secondary, tertiary alcohol شي هذا؟
tertiary.
هذا tertiary alcohol. Okay. Okay, strong acid. That meaning action of electron on the oxygen, it will be attack the proton of the acid. Okay, give you what? Give you OH2 plus. OH2 plus good leaving group or poor leaving group?
good living
Bucci good. Bucci good.
وH بورا بس
زين هكا OH2 plus هكا شو دبنا شيء؟
with the H2
عافية دبنا H2 stable or no؟
stable.
خلاص هكا stable يعني good living group، هكا stable يعني bad living group، poor living group. تمام؟ خلاص stable يعني good living group. تمام؟ اوكي. H2O or H2 plus is good living group. Why? Because when remove the structure or remove from the structure or when this group leave the structure, it will be give you H2O, this H2O. H2O is stable, that meaning it will be good living group. Okay, now, هكا او شو دبنا تشيا دبنا كاربوكيشن. كاربوكيشن ستيبل اور نو؟
ستيبل.
بوتشي نا
لا استاذ ستيبل يعني تيرشري.
ما اعرف يمكن بفرين قلتي نا.
سيدة
خالد بسيدة.
خلد تمام يعني ستيبل اور نا؟ ستيبل. بوتشي
تيرشري لأنه
تيرشري. ليش ايش بالتيرشري ليش يصير ستيبل؟
استاذ لأن 3 عربي.
سيدة چونكي ما يتشارينينا بس بالصحة.
نعم مقصد أبايا بس تيرشري بوتشي ستيبل چونكو سي ار جروب سي الكالي جروب هيا وهر سي الكالي جروب donating or withdrawing؟ donating يعني increase the positive or decrease؟
increase the positive.
عافية increase يعني stable or no؟
stable.
خلاص شو تمام زين. أو tertiary carbocation. Now you have the base. This the base comes from the acid. This acid when lost the proton it will be converted to the conjugated base. معناها conjugated base هذا؟
بلي.
تمام. أو conjugated base now remove the proton from the beta carbon and this bond it will be make a new pi bond here to give you alkene. خلاص. أو mechanism. نوكا زحمة الكيفية this mechanism. Where is the difficult here?
سيدك بس تبدو بيجا.
أو استبدوه؟ خلاص أو استبدوه. أو صح كبيري. OH2 plus. Good living group or poor living group?
Good living group.
بوتشي.
لأن H2O stable.
نا أو قلتي خطوة دوية عادك كي.
لازم سيدا.
تو كي.
أساس. فرزانة سيد.
تمام فرزانة OH2 plus stable or not؟
stable سيدا.
يعني good living group.
Yes.
تمام. Now good living group يعني أبد دبنا good أو DHC دبنا carbocation. تمام carbocation أو stable or not فرزانة؟
stable سيدا.
بوتش stable فرزانة.
يعني أورب.
كي قلت أتاكي تلسيكي ديتي شاوا.
تانو كي قلت سيدا.
من good. تمام ديال أزمن. بوتش stable.
اور الكيل سيد بباي ودونيتن. دي بتا stable بتا good living group.
يعني positive دي بنا بيتشك خفيفة معناها donating for positive charge يعني اوكي يعني increase the stability of the positive charge. عافية فرزانة. تمام خطوة دموع هيكي كي تناقشتي خطوة دموع هيكي؟
بس تناقشتي سيد.
تناقشتي. هي conjugated base. أبا conjugated base أو come from what? From the first.
The speaker.
the speaker. عافية. چونكو strong acid هيا strong acid هكا شو تفاعل دبنا conjugated base معنا؟ أو conjugated base مستقرة أنا؟
لا مستقرة.
مستقرة أو تدفيت بروتون تدفيت حتى دبنا مستقرة معنا؟ الكيف بروتون هيا أو بروتون هيا ما شاء الله تجي بروتون هيا فيري. أوكي؟ تمام. It will be remove one proton. Remove this proton. Okay, remove this proton. And هردو electron make a new pi bond here. خلاص دبنا الكينو H2SO4. Okay? Okay. نوكا واضحة؟
واضحة.
Okay, واضحة. Now, he said here this homework draw the structure of each transition state. He said transition state. and the three-state mechanism. طبعا he said يعني مقصدوي أو شيء مقصدي بنفيسا ميكانيزم همين. طبعا نفسي أو ميكانيزم بالضبط. Exactly the same compound طلبة. Okay, CH3 by 3OH. The same. يعني if I give you this question in your exam, the answer this. Exactly like this. 3 step 1, 2, 3. Okay. Protonation, remove the leaving group to give you carbocation and a new pi bond. تمام؟ Okay, 3 step 1.
خطوة دموهيكي H2 كيفاتشو H2O كيفاتشو؟
H2O؟ خطوة دموهيكي عن خطوة دوية؟
يا دموهيكي.
أو H2O very H2O.
أرسي دازان بس خطوة دموهيكي دونينكا.
لا ما أنا أو ميكانيزم أو نا تفاعل هكا تتفاعل بنبيسا أبايا قال H2SO4 ناتج لبناء الكينا قال H2O بس أو ميكانيزم فنوكا صحكي أو ميكانيزم نوكا خطوة أولي برودكت هيا نا برودكت نينا خطوة دوية برودكت هيا H2O هيا تمام خطوة دوما هيك برودكت هيا هذا برودكت تمام أوكي يعني وقت التفاعل بنفيسا بلس H2O بس ميكانيزم أو ميكانيزم تفصيل هذا أوكي Okay, now the E2 mechanism هكا تواسطي يا هراو باش تحكي محاضرة چونكو وقت هيا
كل كان محاضرة أزبوط مع المحاضرة ده سيدة
چه؟
بيتاب الساعات السيدة مروف خذي خير أنه كانت سحكاتي
لا يا شبكم يعني مادة دريشة طلبة ووقت كيما وأونلاين ناوكي قاعة هكا قاعة زيتنا ديتش ما يعني ناوكي أونلاين بزحمة ترى Okay. I have to continue. I cannot stop. Okay.
مو سيدة كم روشتي نجاش تمرويتش نجرت.
بله أزقل خطوة كخطوة مش كان يعني.
ديال.
بلا باش لسه بيساعد.
إيتو ميكانيزم أو كي تعرف بس بيجي كي. سكفان؟
لا محمد
خورشيد.
نعم.
تمام محمد خورشيد. تو شيء ديتشي هذا مش كاينه باس احكي مع محمد قال ما بيشك خوب بقرا تمام
لسه سعيد بقرتها بس ساعات نيفا
جاوا ساعة نيف ده هوني
محاضرة كان ساعة
2 ساعة هشتا بينجي دقيقة شو
اوه الله اكبر
اصلا تدرنجها احتمال تبيجي ساعة نيف اصلا تنظر كان وقت بس بكيفا
لا والله نظام بس كان قلت بس
ايه صحيح نعم ده هني برا وبنجي دقته. المهم the E2 mechanism for the dehydration of a primary alcohol. This the E1. E2 different طلبة E2 هكا كنجي هكا تا primary كحول هيا not secondary not tertiary okay. And here the E2 mechanism for dehydration of primary because the primary carbocation are highly unstable. Look because the primary carbocation not stable. This primary carbocation it will be come from what? From primary كحول. Okay? That meaning if you have this primary كحول طلبة أو شيء primary secondary tertiary شيء هذا primary alcohol. That meaning primary alcohol give you what? Primary or secondary or tertiary carbocation?
Primary carbocation.
Primary carbocation stable or no?
Not stable.
Not stable. يعني E1 should beat E1 mechanism? No.
E2.
دبنا E2 mechanism. Okay. E2 mechanism فرق شيء فرق هيا. Okay. This I will explain for you. Until you know the difference between the E1 and E2. Now he said because the primary carbocation are highly unstable, the dehydration of a primary alcohol cannot occur by E1 mechanism. Okay, involved carbocation intermediate. Okay, now with a primary alcohol, therefore dehydration followed by E2 mechanism. This is the E2 mechanism. This two-step process of the conversion. Look, two-step process. Okay, conversion alcohol to the alkene with also with strong acid. Acid طبعا as catalyst. Look, خطوة أولية remove the proton from the acid. That meaning the unshapophilic ketone of the oxygen attack the proton, give you OH2 plus. OH2 plus good living group. Yes.
Yes.
Okay. Now,
Yes.
if you remove the OH2 to make carbocation, it will be primary carbocation not stable. Okay. هكا to beige primary carbocation not stable not checkable. خلاص. Okay. That meaning we cannot remove the OH2 plus. Okay. What will be happen now? It will be happen the H2SO4. It will be remove the beta hydrogen. That meaning HSO4, the conjugated base, it will be attack the beta hydrogen, okay? And here make a new pi bond, and the OH2 plus it will be removed as OH2 group, okay? That meaning we have two steps. Step number 1, step number 2. Without carbocation, طلبة بنفيسن, you can hear right here. Dehydration of a primary alcohol by E2 mechanism without carbocation. okay, without carbocation. Okay, just protonation. خطوة أولى protonation. خطوة دوية, the conjugated base, the nucleophile, it will be attack the beta hydrogen carbon here, attack the beta hydrogen carbon to make a new pi bond and remove OH2 plus as H2O molecule to give you the alkene. Okay, خلاص. يعني the E2 mechanism is easy than E1 mechanism. سنة وبسيطة. Okay. Without carbocation, just without carbocation طلبة. يعني the difference between E1 و E2 chia without carbocation. Okay. بوشي chunko primary كحول. Primary كحول give you primary carbocation. Yes. Give you primary carbocation. Primary carbocation not stable. هكا not stable يعني دعيناك تبون فيسا أصلا. This we talk about that before that. If we have carbocation, the rearrangement, it will be happened or no, طلبة?
Yeah, happen.
We said before that if you have carbocation and there is any probability to make rearrangement, make it. I said before that if you have rearrangement and you can rearrange the carbocation from the primary to secondary or from the secondary to the tertiary, please make it. Okay. Now, look to this example. This H2SO4. He said this H2SO4. This any type of primary, secondary, tertiary, anyone?
Secondary.
Secondary. يعني secondary E1 تشيد بيت؟ تشيد بيت. بلى E1 secondary tertiary E1 تشيد بيت بس primary E1 تنابت E2. بنفيسا دفوع طلبة بنفيسا E2 for primary كحول و E1 secondary tertiary كحول بنفيسا ملاحظة وصل بتشيكا بنفيسا. اوكي يلا E1 بوتشيا E1 برايمري كحول. لا ولو بالعكس
سكندري وتيرشري بس
عافية برايمري كحول باي E2 ميكانيزم، سكندري وتيرشري كحول باي E1 ميكانيزم. يلا نوكا او كش كحول هذا
سكندري
يعني E1 لو E2 E1 ها عافية E1 زين هكا كاربوكيشن فيري تشيد بيت ريارينجمنت دي هيا أنا هيا تشاو هيا 1 2 زين 1 2 ميثايل شيفت أو 1 2 ميثايل شيفت يعني أو مثال همي دراكة ديتا فيري دبنات تيرشري كاربوكيشن معنا تمام خلاص وباش إليمينيشن دوما هيك إليمينيشن خطوة دوما هيك إليمينيشن تمام. where is the mechanism? here the mechanism look. Here the mechanism look. Here. Okay. يلا طلبة قال ما حتى it will be easy for you. Okay. Look. بلى دكتور.
أبسلايد بارين كاسينا كاش.
أفا؟
بلى.
تمام. صح كيف. بنفيسا دفتر بيري بنفيسا. Primary كحول by E2 mechanism.
سيدو من بسيا.
خلاص أو همي وصلت بيجت بس هبيت بيجت مشكلة تمام. و secondary tertiary كحول باي تشيا E1 mechanism. هكا secondary carbocation هيا و rearrangement دي هبتن تشيكا. Okay, if you have secondary carbocation and there is any probability to make tertiary carbocation for rearrangement, you have to do it. Okay. Now, look, any alcohol this secondary alcohol. That meaning if you remove this OH and it will be here carbocation, it will be secondary carbocation. Yes. هكا secondary carbocation rearrangement هيا أنا.
أكون حاولت tertiary بين.
تمام أكو. يعني هاي CH3 مع الالكترونين مالها راح نشيلها it will be 1,2 methyl shift 1,2 alkyl shift okay 1,2 alkyl shift والpositive راح تجي هنا the positive will be convert to here that meaning this positive it is now secondary or tertiary carbocation
لحظة tertiary.
tertiary carbocation. tertiary carbocation by rearrangement. Okay, by rearrangement. خلاص. This carbocation can rearrange more stable carbocation to shift one of the hydrogen atom or the alkyl group. Here we have 1,2 alkyl shift. Look here, you have this carbocation. 1,2 alkyl shift. Your carbocation will be tertiary. Okay. اوكي او سلايد يعني هو همي نبيسي اوصل بس اثبتها من شرح كمان. Now this movement of the hydrogen atom is called 1,2 hydrogen shift. We know that. Movement of the alkyl group is called 1,2 alkyl shift. Okay, hydrogen shift, alkyl shift. تمام. 1,2 shift convert less stable carbocation to more stable carbocation. تمام طلبة؟ How you take it before that. Look, take this example. For example, secondary carbocation or secondary carbocation. Mana? This secondary carbocation. This A. It will be rearranged to more stable carbocation. By what? Anyone? Methyl shift or hydride shift this?
Hydration.
hydride معنى hydride؟
يعني H ليش تجيبه؟
هيدروجين
يعني H قال هردو الكترون H ماينس يعني. تمام. هيدرايد يعني H ماينس. هكا H جبتني شيا او هيدروجين. اوكي هكا هيدروجين بي الكترون شيا وبروتون شيفت. تمام. بروتون شيفت. But here we have hydride shift. Hydride meaning hydrogen with both of the electron. قال آصرة. همي راكا ودانا بيري. 1,2 hydride shift. اوكي. 1,2 hydride shift. زين. هكا 1,2 hydride shift شيبو دبنا شيا tertiary carbocation. Anyone is more stable?
Tertiary.
Tertiary carbocation. Now, look to this. This any type of carbocation?
Tertiary no
tertiary carbocation.
بوتي.
زي
تدرنينا. زي تدرنينا. خلاص أو tertiary. Okay? Okay, that meaning we don't have any rearrangement here. Okay. The mechanism, this is the mechanism. Again, you have this كحول, you have acid. Okay. Look to the كحول. كحول primary, secondary, tertiary. Any كحول this?
Secondary.
Secondary. Any mechanism?
A2. A1.
A1 عافية. A2 تثبيت؟
لا بس
بوتشي لا.
أو بس برايمري.
بس برايمري.
بوتشي يعني بس طبوا هاتي وصل بوتشي.
إشبار stable أو not stable.
إشبار primary كحول give you primary carbocation not stable. Okay. You have to say this. Okay, now, Afia, good, very good. Now, look, this we have strong acid and we have unshape of electron. That meaning unshape of electron for the oxygen attack the proton to give you OH2 plus. OH2 plus, good living group or poor living group?
Good living group.
يلا good يعني تشد بديتي أنا.
روح.
تمام تشد بديتي هكا. We remove. If we remove the OH2 plus, it will be give you secondary carbocation, okay? Secondary carbocation, no problem, is stable. Rearrangement هيا أنا. هيا. يلا check. هكا هيا check. خلاص. 1,2 hydride shift or 1,2 methyl shift?
methyl shift.
Benvison vary 1,2 methyl shift. 1,2 methyl shift, okay? أبا 1,2 shift أبا بشكل عام. 1,2 hydride shift هيا. 1,2 methyl shift. Now, 1,2 methyl shift, it will be give you what? More stable carbocation. It is tertiary carbocation. تمام. No, كخطوة دوما هيك elimination. The conjugated base here remove the beta hydrogen and this of both of the electron make a new pi bond here. خلاص, it will be give you alkene. Okay? Then, now look to this carbocation. This carbocation. How many different type of beta carbon we have?
2.
أبا هيك وأبا وكأبا معنا؟
بل.
يعني we have beta 1, we have beta 2, beta 2. Okay. هكا 2 different type of beta hydrogen we have. يعني كم product هيا؟
2.
If you remove this hydrogen, give you this product. If you remove this hydrogen here or this, look this. It will be give you this product. Anyone is the more stable one, the major one? This or this?
Yes,
sir.
Why?
More
Okay, more substituent alkene. This more substituent alkene. this less substituent alkene. Okay. تمام؟ يعني this is the major one, this is the minor one. واضح عنا؟
واضح.
واضح. Look, this homework. No, not homework. أصلاً هو محلول. Okay. Show how the dehydration of الكحول. Okay, this كحول primary, secondary, tertiary chia.
Secondary.
Secondary. كيش mechanism?
A1.
A1.
A1 mechanism. بوشي A1 mechanism.
Very stable.
لأنتي؟
Stable carbocation.
عافية. Stable carbocation. عافية. Okay. الحال chia. Now, solution. Okay, now show how the dehydration of alcohol, this alcohol, form alkene using 1,2 دي. تمام. يلا. Any mechanism? A1 mechanism. Carbocation هيا أنا هيا. يلا. Check in هذا. Step number 1, protonation. This it will be attack the proton, give you good leaving group. Remove the leaving group, give you carbocation. This carbocation secondary. rearrange هيا أنا
هيا
عافية هيا. زين هيا.
بجاهدي.
هيا فيرخي أم فيرخي؟
على
داستشاب
دستشاب. بوشي دستراس.
راح يصير برايمري.
هكا دستراس ضمن برايمري أو خرابترا يعني. تمام؟ No, we want this. It will be destchap. It will be from the left. We have to remove. Okay, from the left, what we have? We have alkyl or we have hydrogen? We have hydrogen. That meaning 1,2 methyl shift or 1,2 hydride shift?
Hydration.
Yeah, 1,2 hydride shift. That meaning the hydrogen with both of the electron, it will be moved to the carbocation and the positivity you convert to here. Now, this carbocation is stable or no? Stable. Tertiary carbocation, more stable carbocation. Okay. How many different beta carbon we have?
Do egg
1.
No.
egg side.
This beta carbon, mana? With this like this. Yes? That meaning we have 2 type beta carbon. Okay. Anyone, that meaning we have 2 type of a product. We have, if you remove this proton, give you this product. Yes? If you remove this proton, give you double bond here, double bond here. Okay, you have. But anyone is the major one? This?
هذا side.
Ava Bucci.
Or
More substitute.
More substituent. Okay, good. More substituent. Okay? More substituent. Good. You have to write it. Look, you just look to the starting material at first. If you have كحول and acid, look to the starting material. Okay. كحول acid خلاص other elimination. كيش elimination E1 and E2 وصف. Okay. You have to think like this. E1 or E2 هكذا قلتي E2 يعني خلاص carbocation نينا ودو خطوة وخلاص تشوف. هكذا قلتي E1 يعني carbocation هيا وهكذا rearrangement هيا rearrangement check أو pass elimination. تمام؟ تمام. Show what? Show how want to shift from the more stable carbocation for the. Oh, okay. Now look, he give you this carbocation. He want to shift to make a more stable carbocation. Okay? To make يعني just rearrangement check طلبة أو rearrangement check. Okay, you have to do the rearrangement. Okay, this anyone methyl or hydride shift?
Hydride.
Hydride.
Hydride. Okay, hydride. Because we have hydrogen, we don't have methyl here. Okay, you have to write it. If you have methyl, you can check the methyl. If you have hydride, okay. Now this.
Methyl side.
Hydride.
Hydride. Our hydrogen. We have hydrogen here. Okay, we have hydrogen here. On this carbon, we have hydrogen. Hydrogen will become to here, the positive will become to here to be tertiary carbocation. Okay, this
Methyl.
عافية methyl shift. Our hydrogen hydride shift نينا بيري بس methyl. Okay, this and this anava راكا ودانا بيري. Okay. Okay, explain how the reaction. He said explain how the reaction. Explain how the reaction of this compound. What is that? Just okay. He said here, explain how the reaction of this compound with H2O yield to substitution of product. This and this. Okay, how? You have just write it on the paper, طلبة. You will easy. It's so easy. Okay, you have to know why it will be give you two product. Now, ساعة شنوكا. تمام. Okay. Okay. I will. This, inshallah, it will be next lecture. Conversion of alcohol and alkyl halide with HX. Okay, to alkyl halide with HX. يعني reaction of alcohol with HX. Okay. This it will be next lecture, inshallah, and re-listen again to this lecture, and please resolve all the homework and repeat, write the structure, the mechanism, all the thing. It will be very easy for you. Okay. Now I will stop recording.